All right, so we've already talked about how to do radical equations, how to solve them. Now we're going to figure out how to solve rational exponents in equations. So an equation that has a rational exponent is simply an equation that is raised to a power that is a fraction. For instance, x minus 2 to the 1/2 equals 9. Now we know that this is saying the same thing as the square root of x minus 2 equals 9. We know that those are equivalent statements. But when you're in this form, it is a little bit easier to handle it just a little bit differently, especially when this numerator is not a 1. So just like when we are doing square root equations, we are going to just simply square both sides or raise both sides to the second power. When you do that, this 1/2 times 2 becomes 1. So the the left side of your equation becomes x minus 2, and the right side becomes 81. Now you have that linear equation, you just add 2, and of course you need to check your answer to make sure you don't have an extraneous solution. Let's look at another example. This one now is a cube root, or it's raised to the 1/3 power. The steps are exactly the same as when you are solving a radical equation. You need to isolate the variable. The radical. So you want to isolate this x plus 4 raised to the 1/3. So the first thing you're going to do is to subtract the 5. Now that you have the radical by itself, you are going to raise both sides to the 3rd power. So you've got x plus 4 raised to the 1/3 raised to the 3rd, so this just becomes x plus 4. And then you have 3 raised to the 3rd, which becomes 27. Now you have a linear equation and you can just solve. Since this is a cube root instead of a square root, you don't need to check it. It's always a good idea to check it to see you've made a mathematical error, but you will not have an extraneous solution. Let's try another one. Now this one does not just have a 1 in the numerator, so in this case, your radical is already isolated, but now you're going to raise both sides to the reciprocal power. So you're going to raise both sides to 2/3. When you do that, your 3 over 2 times your 2 over 3 becomes 1 again. So the left side is 2x minus 3. And we know how to simplify this 8 to the 2/3. Remember, you're always going to do the denominator first, which is your radical. So you're going to take the cube root of 8, and then you're going to square it. So the cube root of 8 is 2, 2 squared is 4. And now you have a linear equation, which you are just going to solve. Since here in this step where you raise it to the 2/3, you're really taking the cube root, so you will not have an extraneous solution. You could also raise something to a negative power, and so now in order to kind of undo that radical, you're going to raise it to the -2. Because you want this power raised to a power, you always want that to multiply to 1. So on the left side, we'll have x minus 4. On the right side, we have 1/5. If we simply square that, we'll get 1 over 25. And then if we take the negative, that means flip it, so it'll be 25. And you will add the 4, and of course you will have to check your solution because, oh no, you don't have to check your solution because you're squaring it. So now we have something a little different here. Let me just erase this real quick. Well, I don't know how, so we have 2x minus 1, and we're raising it to the 2/3 power. So now you notice that there is a 2 in the numerator. You know that when you flip that, you are going to have a 2 in the denominator, which means you're actually square rooting this. So you're going to have to remember that you're going to have plus or minus in your answer. So sometimes in the very beginning of the problem, when I see there's a 2 in the numerator, I'll kind of write this plus or minus in here so that I don't forget to put it on when I'm solving the problem. So you're going to raise both sides to the 3 over 2, the reciprocal of 2/3. And so now what you're really doing is you're taking the square root of 25 and then raising that to the 3rd. So that's why you're going to need to have that plus or minus, because you're square rooting it in an equation. Now you actually have 2 equations. You have 2x minus 1 equals positive 125, or 2x minus 1 equals negative 125. Excuse me. So now you can solve each equation separately, and you'll get two answers. And now you'll have to check them because you are taking the square root. Now, once again, your numerator is a 4, so it's an even root, so you're going to need to have your plus or minus when you raise both sides to the 3/4. So once again, the left side becomes x plus 3. And if you take the 4th root of 16, you get 2. 2 to the 3rd is 8. And again, because it is a 4th root, you need plus or minus 8. So you'll have two equations, solve them separately, and check your answer. Now, we're going to do some inequalities, which are going to be handled a little bit differently. So we have 4 times the square root of x minus 2 is greater than 20. So the first thing you do is just solve it as if it was an equal sign. You're going to isolate the radical, so you're going to divide by 4. And then you're going to square both sides, and you're going to get an answer. X is greater than 27. But now you need to take another step. But because we know that we are only dealing with real numbers, we know that what is underneath this radical has to be positive. So what we're going to do is we're going to set up an inequality to find out, well, what will make this underneath the radical positive? Well, if I say x minus 2 has to be greater than or equal to 0, that would force it to be a positive number. We know that x has to be greater than or equal to 2. Any number 2 or greater will make this 0 or positive. So now we have two inequalities. X is greater than 27, but we also know that x has to be greater than or equal to 2. So we're going to graph both of these on a number line. So if I says x is greater than or equal to 2, I'm going to put a solid dot going over here to the right, and x is greater than 27. So now what I'm going to do is I'm going to look at these two, and I'm going to look where do they share both the red and the green arrow. Well, over here where x is greater than 27 is where they both are, so that is what my solution will be. Let's try another one. We're going to isolate the radical, so we're going to subtract the 20 and divide by 4. We're going to continue to solve this by squaring both sides and then adding the 8. So now we know that x is less than or equal to 24, but we also have to make sure that the numbers underneath the radical are going to be positive numbers. So we're going to set up another inequality saying x minus 8 is greater than or equal to 0. That's what will make it a positive number. So we know x has to be greater than or equal to 8. So we know both of these inequalities have to be true together. So we're going to put them on a number line. X is greater than or equal to 8. X is less than or equal to 24. We're going to look to see what region do they share. Where is there both the red arrow and the green arrow? And they share numbers between 8 and 24. So we're going to write a conjunction saying that x has to be between 8 and 24. All right, why don't you put the video on pause and see if you can do this one yourself. All right, let's isolate the radical. We'll subtract 3. We will divide by 6. So now we know that the square root of x has to be less than or equal to 2. We will square both sides. And we know that x has to be less than or equal to 4. But we know that x also has to be greater than or equal to 0. So we're going to graph both of these inequalities, and we're going to look for where do they share all the points. Well, there's the red and the green in between 0 and 4. So your final answer is a conjunction where 0 is less than or equal to x is less than or equal to 4.